So I'd like to welcome Josh Caldwell-Clark and Adam Pease, who will now provide an overview of our 8th grade algebra program to the Board of Education.
Thank you, Christine. So as Christine mentioned, we're going to present some information on the 8th grade algebra program. Just in terms of how we've organized the presentation tonight, we're going to spend a few minutes talking about the history and enrollment trends, give you a program summary and kind of belief system around the program. We're going to do a little curriculum side by side so people can see, the board can see the 8th grade program compared to the algebra program. Josh is going to summarize some algebraic thinking skills and then talk a little bit about the instructional model, how we support all students, whether they might need some additional support or some enrichment. Talk a little bit about high school pathways and share what is in the decisions booklet with regard to choices that students and parents make. And we're going to share quite a bit of data. We have some data pre-pandemic from when we had the two-class model as well as the data from the model now. And talk a little bit about feedback and adjustments and recommendations for next steps. I will say that we're not here to sell the program or to defend any decisions that we made. We're really here to just provide information. To have a discussion, have continued discussions about decisions going forward, and hopefully we'll be able to make the best decision for our students. I know the parents have come out and would like to contribute during public comment, and certainly the board has questions. So we're going to try to provide a real foundational presentation that will facilitate and support that conversation. All right, so just in terms of history and enrollment trends, and I know for some of you this might be new information, and for many of you, you know this, but just as a reminder, prior to or up to 2017-18, we had entrance exams. We had two different courses. We had a Math 8 course and we had an enriched algebra course. There was an entrance exam with criteria. There was kind of a cutoff, and certain students were admitted to the program and others were not admitted to the program. We opened enrollment for 2018-19 and 2019-20. And that's when we started to see a shift of enrollment. I'm going to share some of that data in just a minute, but we continue to run Math 8 and enriched algebra, and we kind of flip-flop from like a 60-40 to a 40-60 with about 2/3 of students in enriched algebra in 1920. 2021 was the year of the pandemic. We had Algebra 8, that was the first year of it. That was when we had the cohorts, we had remote learners, we were teaching ELA and math in large spaces. We were able to get all of our students in every day during this time, which was a unique situation and something we're really proud of, I know, but it didn't come without challenges, and it forced us to make a decision where if we continued to run, we basically had to decide if we had students come in every other day, we could continue to run our master schedule with the two courses. We decided we'd bring students in every day. One of the sacrifices that we had to make, or decisions we had to make, was around the math courses, because we were getting guidance from the Department of Health at the time that we shouldn't be mixing and remixing the students. So if we were to continue with an advanced math course in 8th grade, those students would be cohorted all through their subjects through the day. And that was something we didn't want to do. And so then we were kind of pressed into this decision of algebra in 8th grade for all students in 2021. That was during the pandemic, and obviously this year we have Algebra 8. We have made some shifts, so there's 53-minute classes. Those classes were shortened during the 2021 school year, and you can see some other adjustments, which we'll talk more about in just a minute. I did want to share that we have heard from the community. We've had questions about the level of communication, and this is a list, although I know it's very a text-heavy slide. It is a list of communications that we had between March of 2021 and April 2022. These were all letters that we sent out to parents, as well as focus group surveys, webinars, etc. And I understand that all of these did not go out to the whole community. Some were targeted towards 7th grade parents, others towards 8th grade parents and students, etc. But I did want to share that communications. This is a graph just showing that enrollment trend shift, where blue is the enriched algebra, and you can see that increase over time. Up to that 2019-20 bar all the way there on the right. And I anticipate that shift would have continued had it not been for COVID and us shifting the model. And it is of concern. One of the things that could have potentially pushed us in this direction anyway is the makeup of that red bar and which students are there and what that trend looks like over time and how small does that class get and who is in that class of Math 8 while the majority of students are in enriched algebra. So just a summary of the Math 8 program, all 8th grade students take Algebra 8. Students are supported through Enrichment throughout the year. All students take the New York State Algebra Regents exam, and they also take the Math 8 assessment. And when they do that, then we count the Math 8 assessment. And by count, it's just part of the New York State accountability system. We have to count a Math 8 assessment during the 8th grade. And by also taking the Algebra exam, that counts as their high school exam as part of the New York State school accountability requirements, and that frees the students up then from having to take a Regents exam at Greeley, which gives the high school math department a lot more freedom with regard to course design because they're not locked in to take a Regents exam. Some students will go on and choose to take the Algebra Regents again, in which case we'll replace on their transcript whichever score is higher on the Algebra Regents. Students receive high school algebra credit and are exempt from their geometry Regents, as I said. All right, so just a little overview, kind of a program comparison side by side with the two-course system, Math 8 and Enriched Algebra. You know, it was more in line with the regional norm. You find that in schools that are similar to us in the area. It gave students and parents more choice and an increased feeling of fit. There's really two options there. If we have an entrance criteria, like we had previously, we have concerns about the validity of that criteria. It's historically challenging to predict success of middle school students in any subject. So when you start to put together criteria of using entrance exams or averages in courses, it's invariably unpredictable. And it does provide, for both of them, provides this idea of inequity and tracking very early on. And then as we add the current system, one-course system is Algebra. You can see the positives. 5 years of high school math is available to all students. More students have the opportunity to potentially take calculus as seniors. It does delay that tracking decision until high school, so they have time to develop their algebraic thinking, keeps heterogeneous groups through the middle school as opposed to tracking them into the two different tracks, and supports equity and inclusion because all students have then the opportunity for 5 years of math. And some concerns, you know, the level of rigor with regard to fit for students. Is it too rigorous or not rigorous enough? Challenges with differentiation in that heterogeneous group, and a feeling where students or parents or a faculty member may feel there is not a good fit and another option in the course. So these are some of our guiding principles, and I understand that everyone won't necessarily agree with these things, but I believe that early tracking disadvantages more students than it helps. When it comes to middle school tracking, I think early tracking has a disproportionate and negative impact, and too often a predictable negative impact on certain populations of students. I think access to rigor matters for all students. Access to 5 years of high school math matters for students. We hear that from colleges repeatedly. Access to a strong algebra curriculum is a key indicator for future mathematical success, so focus on 8th grade algebra, I think, is a good choice as opposed to some of the other topics in 8th grade math. And early selection systems are not predictive and are therefore inherently unfair when it comes to middle school tracking, early middle school tracking systems. All right, so what's our goal for this program? I've been asked that by community members, and so here's what we're trying to accomplish: a more equitable access to advanced, rigorous coursework, delay the high stakes, high pressure decisions of choosing a track, which students had to previously do in 7th grade, rigorous 8th grade math program for all students, and then maximum student growth. That's what we're trying to accomplish, trying to avoid this fixed mindset communication about who's good at math and who's not good at math, early high stakes decisions. We're trying to avoid a high ability track and low ability track with predictable inequities, as I mentioned, and trying to avoid this kind of high stress, high stakes decisions that would have to happen pretty early on. All right, so Josh, I'm going to transition over. We're going to do some research on algebra.
So starting with looking at some national research about algebra, and this study talks about how a strong foundation in algebra for all students is the highest predictor of longitudinal success in mathematics and sciences over the course of high school and college. And then another piece of research showing us that starting to track students early starts to lead to lower mindsets of students and develops this idea of a fixed mindset of students that are in lower tracks feel like they can't do math. It also, this study showed that achievement was linked to this early tracking, and also talked about how student mindset was linked to early tracking, as well as students not being able to catch up in curriculum from this early tracking, so they were constantly falling behind over the course of their high school career in mathematics. So next we want to talk about comparing Math 8 curriculum versus algebra. So one of the things to notice is that Math 8, there's a lot of text on this slide, but the crux of it is that there's a large overlap in Math 8 and algebra curriculum, and that's on purpose. The state has said that there are ways to have students take both Math 8 and algebra at the same time, so you have a large overlap. We have consciously thought about that and thought about what Math 8 topics can be taught in 7th grade and what topics in 7th grade can be taught in 6th grade. And this is actually all supported by our Math and Focus K-5 implementation, which has always gone over and above the Common Core standards of each grade level. So the most important thing that we have talked about in the research and in our principles is that algebraic thinking is a skill that students need to see and understand that we all use in our daily life every single day. And having an 8th grade algebra experience and an in-depth algebra experience is really important to have students developing their algebraic thinking skills. But it doesn't start in 8th grade. We don't start teaching students algebra when they get to 8th grade or when they take a formalized algebra course. The question that we have up here is a question that is in our 3rd grade Math and Focus curriculum, as well as essentially comes back in our algebra curriculum. The only difference between the two at that point is that we start to formalize the variables and use letters for those variables. But you can see that the red boxes are a version of us teaching students this variable thinking before they even get to algebra. Too far. And then this is a large text from the National Council of Teachers of Mathematics, but it really talks about how important algebraic thinking is. And it also shows us that in Chapter our use of a concrete tutorial to an abstract algebra method of teaching, beginning as early as kindergarten, 1st and 2nd grade, really supports the idea that we are developing algebraic thinkers in our curriculum. The other core component of an algebra program is the development of functional thinking. So the idea that there is an output by doing something to an input and looking at those patterns is the core piece of developing from algebra to geometry to trigonometry and then up to calculus. So this is a large core component of our algebra curriculum. So I want to talk about our instructional model. And it doesn't mirror what we think of as a traditional math classroom that probably looked like when we took algebra back in middle school or high school. The first piece of it is each class starts each day with an activation. These activations have what we call a low floor and a high ceiling. They have entry points for every student in the class. You might have a student that asks which one doesn't belong and say that the -3 because there's no x attached to it. Or you might have a student say the -3x squared because it's a quadratic expression, right? So you have lots and lots and lots of different options for students to be participating and engaging from the second that they walk into a classroom. Rather than doing a problem from the homework from the night before, it's questions that can engage all students. Another one here is a same but different. So students are asked to use their whiteboards at their desks or on vertical whiteboards in the classroom to just simply look at these problems and say, what is the same about them and what is different about them? You do see lots of students starting to solve these quadratic equations. You do see students looking at them in ways that say one is on one side, one is on another side. But you have lots and lots and lots of different entry points for all different types of learners in the classroom from the second they walk in. A big piece of the core instructional component of our classes is whiteboarding. Using whiteboards, using vertical whiteboards and horizontal whiteboards takes takes the formality out of taking notes in a classroom. It allows students to feel like they can be creative. It allows them to feel like they can erase anything that they need to revise. And it also allows a teacher to be walking around a room and very easily see where every single student in their class is at and what exactly they are doing, to be able to formally assess their students in their class, to make decisions in the moment of how to proceed to the next activity in the classroom. This work is done by Peter Liljedahl. He has, we have read his book, we have looked at his research, and we've really implemented a lot of his work around taking students into a growth mindset for mathematics, looking at lots of different assessment methods, and allowing students to really grow at their own pace, rather than us standing at the front of the room and teaching them mathematical concepts, but rather having them to develop their own mathematical learning. Our approach to homework has been in two different ways. One is every homework assignment that's on paper that has gone home with our students has an A level, a B level, a C level. Generally, we have students do the B level and choose if they want to go and do the A level work to either review what happened in the previous class, to then develop their learning, or do enrichment work that would be the C level. We have students, some of them come in and do all three levels. We have some that do just the A level. We have some that do the C and the B level, and every permutation. And that alone is a way for a teacher to assess their students in their class. We also utilize a program called Delta Math, which teachers can assign different problem sets to students. So each student in the class doesn't necessarily get the same problem set. They could get problem sets that really are targeted towards their learning needs. And it also has options for students to practice additional work. They get instant feedback, and the teacher has fine-tuned controls over what students see what type of work. And all of this leads to, as opposed to lots of whole group instruction, where essentially a teacher is either lecturing or developing the same thing for the entire class, our students are working in small groups in lots and lots and lots of times during their class. I've walked into classes and I see some students working independently while a teacher is coaching into another group, while another group of students are working as a group with the work that they're doing. So the idea of that is that a teacher can think about a unit or a skill that they are teaching in terms of a band of learning for students, and can start to work with the various students that are in their class to decide, okay, this group needs to work on this piece of mathematics, this group needs to work on this piece of mathematics, and then at times they will mix up the different groups and start to do some collaborative learning with all of them. And this is all actually interspersed with some short bursts of whole class instruction. If you walk into our rooms, you see lots of anchor charts around the math that summarizes the work that's going on in that unit. You see lots of student work on walls, and you see lots of students being actively engaged from the beginning of the class all the way through until the end of the period. We want to talk about the assessment model that our teachers are using to learn how our students are doing in class. Utilizes summative assessments, right? So students do take tests in these classes at the end of the units and quizzes throughout. But everything that I just outlined is a method for teachers to assess the learning of our students and decide what gets taught the next day, what gets taught in that class, and how to guide the homework for the students and how to guide any individualized support that students need. So it's a multi-tiered assessment model. So I think this is an important slide to spend a little time on for us to talk about. We have built in many supports with the resources of the school district and the resources of our faculty in order to provide an environment that really is multi-tiered and differentiated throughout the classroom. So starting with everything that I just outlined about differentiation and leveled activities in a classroom, to utilizing our STEAM teachers, Tabitha and Jenny, pushed into the math classrooms. We have extra help after school for our students. We also have AIS support for students that need it. Our special education teachers have been part of the professional learning around mathematics from the beginning of this year, and have really been huge supports when they're consultant teaching in the classrooms with the teachers that they're working with, and also working in learning centers and in a variety of different places to support our students and our E&L teachers as well. We have done a considerable amount of professional learning with our faculty, including learning walks, including coaching sessions, including reviewing our curriculum, assessment, development, homework development, and really over the course of this year, fine-tuning the instructional model. So there are many supports that we built into year 2 of our algebra program. We also have built in lots of safety nets. So students at the end of 8th grade can decide to take algebra again in high school. We have 2 courses that they can take that would replace the 8th grade score on their transcript, as well as allowing them to have the highest of their Regent score, algebra scores on their transcript. Students can receive credit with a 65 or higher, or if you're a student with a disability of 55 or higher on the Regents. And it also allows us to be free from future math Regents exams, having the students take the algebra Regents in 8th grade, which this examination, the Regents examination, is a high school graduation requirement. So this, we talk about how the 8th grade assessment generally is more challenging than the algebra Regents, since this is a New York State graduation requirement, so that frees us up from into high school for students to have to take another Regents exam. So just to talk about the enrichment that has been happening in class, we've already talked about leveled homework and differentiated homework that students have and the differentiated activities. Our STEAM teachers have been doing push-in and pull-out enrichment. Just a couple weeks ago, one of the activities they were having them in enrichment pull-out with our STEAM teachers was modeling a ball launcher and learning about vertical motion. So the students were learning how to use quadratic regression to model what the pathway that the ball that they launched took, that they took pictures of, and then put onto their computers and model that. So they've been doing a lot of enrichment work. And we also want to make sure that we highlight our Science Olympiad Club, our STEAM clubs, and our Math Counts Club that students are taking part in. Traditionally, these are the 2 pathways that students would take through their high school math experience. If they took Math 8, you'd see algebra, geometry, trigonometry, and pre-calculus. And if you took algebra in 8th grade, you'd take geometry, trigonometry, pre-calc, and calculus. Those are the traditional standard math sequences that high schools generally take. Because of having algebra in 8th grade, I know this slide is hard to read, has lots of information on it, but it allows lots and lots of different options for our students once they enter high school. So they don't get locked into a track, and they have options to move throughout tracks. I know there are solid lines here, but many of these courses have dotted lines for students to move throughout. And by having them take algebra in 8th grade, it gives them more opportunities to move through tracks as they develop through high school and as they develop as learners. I want to review what the 9th grade courses that are available to our students for incoming freshmen. So one of the courses are algebraic thinking courses. The first one is Essentials of Algebra, which is for students that really need to take a second year of algebra, or they need to brush up on their algebra skills before they enter into a geometry course. That course is entirely structured around algebra. The next course that also, students have the option to take the Regents at the end of is our Cornerstones of High School Mathematics course. And that's for students who would like to take more algebraic thinking, would like to learn more about their algebraic thinking and build their skills, but also would like to start to build their geometry skills to then enter into our geometry course or our enriched geometry course. So both of those courses end in the option of a Regents exam that can then replace their 8th grade scores from their high school transcript. Typically, we see the majority of our students taking either geometry or enriched geometry. So this is best for students who have been successful in Algebra 8, and it encompasses the majority of our students. And then the last course, the 5th course that's an option, is our Math 9 Honors course, which is the course that students would take Calc BC as juniors. And this is for our highest achieving students, our students who do incredibly well in Algebra 8. It's based on teacher recommendation and also their scores in Algebra 8. And that takes them through basically through Calc BC as a junior and then in advanced topics in college mathematics as seniors.
So as we go into some of the data that we pulled, I want to start with just some of the challenges and our thinking around data validity. It was particularly challenging as we looked at some of the sources that we traditionally use. Like this is the section of so does this work and who does it work for? Like who's learning and how do we know? And so we think about using the New York 3 through 8 assessments. We're shifting the curriculum, so we're not teaching that Math 8 curriculum. So it's hard to compare the Math 8 scores of before to now because that's not our focus and not our curriculum. And in addition, the exam wasn't given in 1920, and last year we even recycled some questions. So some students had used some practice questions. I presented and shared that with the board, so that's a challenge. The Regents exam, we'll have Regents scores obviously at the end of this year, but we don't have them yet. And to compare cohorts, we were only giving that Regents exam to a select group of students, and now we're giving it to all students. So it makes it challenging to do like a pre and a post assessment using the Regents exam, and then to use course grades or course averages or test grades. We've redesigned the course and the assessment system in a way that makes it challenging to compare pre and post. So what we do have, and it's fortunate that we do, is we have the NWEA MAPS data, and the MAPS assessment is not designed to be an algebra assessment, it's designed to be a mathematics assessment, and it'll measure achievement and growth. So what this slide shows is that this is when we gave them the MAPS assessment to the students. Unfortunately, we gave it in the fall and winter pre-COVID in 2019-20, so that's our previous model. We have data from the fall and from the winter, and so by having those two measures, we have a growth measure for 1920 with the traditional, two-track model. Then we have the cohorts of that was the pandemic year there in the middle. We gave it fall, winter, spring, but so we can compare again fall and winter. And then we have this year's fall and winter. We haven't yet given the spring assessment. So this does give us a standard, and this is a nationally normed test, and the national norm does not change over time, so we can compare our students to that national norm. And then, like I said, it's not an algebra test specifically, it's just that we can get an overall sense of how students are doing mathematically. Our parents are used to seeing these reports because we upload them up into the backpack, and one of the nice things about the MAPS assessment is it gives us both a growth score as well as an achievement score. So you can see students that may be high growth but low achievement, or high achievement but low growth. You can see both of those measures on a student's report. And it also, the MAPS score, parents are familiar with this because we also upload this chart into the backpack, and they can see their student tracking along this trajectory, and they break students down into subgroups, which we'll share some data here in just a minute. So this is our first chart. I think Josh is going to talk us through this one.
Yeah, so Adam had talked about, you're going to see charts that either have growth on them or have achievement on them, or both. So this first chart has our winter 2022 MAPS assessment. And you can see here it's broken out into quintiles that our 8th grade cohort has the highest group that is high achieving of any of our middle school students. So you can see the green and the orange bars are the highest, where our low, average, and average are some of the lowest of our students in there.
So it's a good thing. The skew to the right is a good thing in this case. The higher that right side is, the better, the more achievement you're getting out of that particular grade at that time, in this case, winter of 22.
Right. So in this one, you see, this is our fall to winter growth. And this is how much in our current program, students are growing within the instruction that they're having from early fall to midwinter. And you can see in 8th grade, the growth, the green and the orange bars, right, in our high, average, and our high, those are the highest bars of any of our 4 grade levels in middle school. And on the left side, where we see the blue and the red, those are the lowest bars. So we are seeing that students are growing at a very high rate in our 8th grade classes as compared to our 5th, 6th, and 7th grade classes. Here we did a comparison of the achievement of fall and winter from 1920, right, which was pre-pandemic, and then 2021, and then 21-22. You can see here again the growth average has gone up substantially in all 3 years, and with our stratified model in 1920, in Algebra Year 1 in 2021, and then Algebra Year 2 in 2021-22. You can see that the scores of the achievement are lower coming into that. We could attribute that to what we talked about earlier, our class sizes in 7th grade being shorter and in large rooms. But we see the growth in this year to be the highest and well exceeding the norm grade level, which is the internationalized norm that MAPS sets based upon all of the data that they've had from their studies of students in 8th grade that have taken the MAPS assessment.
So I think if we had only one slide to share with you, this would probably be the one that we share. And I say that because in 2019-20, the average RIT growth for chapel class students in 8th grade was a 0.6. The norm should be 3, right? So the national norm should be 3 RIT points. With algebra for all students in 2021, despite the challenges of smaller, cohorts in cafeterias and gymnasiums, some students learning remotely and shortened classes. We shortened classes to I think 42 minutes from 55. We still got an increase, you can see, of 2.2. So we went from a 0.6 growth, the number of times, that's a 4 times, increase to get the 2.2. And then with the adjustments that we made this year, we're at a 4.7. So we finally got to a point where we're above that 3. So I think it's a really important slide because the MAPS score is not just measuring algebraic thinking, it's also measuring geometry, measurement, and data, and also numbers and operations. So, and again, it's a nationally normed measure. So I think it's a powerful data display. So then we wanted to dig in and say, okay, within that, who's learning within subgroups? One of the things that we have heard quite a bit about was our lowest, like our students that are struggling in math, that this isn't a good fit for them. They need Math 8. And our students that are the highest achieving in math, this isn't a good fit because they need an enriched algebra experience. And so what we did is we wanted to look at the growth based on the achievement. So we took our students and we sorted our students based on achievement. So we have the lowest achieving 25% to the left, then our medium low, 25% is the second one, medium high, and then highest achieving. So you can think of this as the students towards the left would likely be in Math 8, and the students towards the right would likely be in enriched algebra. The blue bars are the 1920 growth scores. So the students actually, the blue bars, because they're 1920, that's like the bifurcated model where we had the Math 8 and enriched algebra. You actually see the lowest achieving students regressed. They didn't grow at all. It was a negative 2.7 compared to this model where our students that achieved had the lowest achievement on the MAP score actually grew a 0.8. You can see for the medium low, again, the red bar is this year, the blue bar is from the previous program in 1920, and you can see that go up. So our highest achieving students actually grew the most in this program. They had grown 3.9, so they had exceeded that national kind of norm, but in this new model they grew at 7.6, which is just an incredible amount of growth for those top kids. And you know, we don't have, from maths, we don't have a breakdown of what your bottom quartile should score. We can't necessarily say it should be a 3. They only give us the 3 RIP points as an average. But we thought this was, again, more powerful data, because when it comes to who is this program helping and who is it hurting, it shows us that it is significantly helping, based on these data, all of these different subgroups, regardless of achievement. And you know, that's something we need to do some work on, is how are we differentiating to support and enrich so we can get that 0.8 up higher. But it certainly shows us a difference in the models and a more positive impact for the model that we have now. So we also broke the data down in the same way using race and ethnicity data. We also wanted to look across like total students, but also white, Hispanic or Latino, Black and African American, Asian and multiracial. And it's the same layout of 1920 compared to 21-22. The 1920 is the blue bar, the 21-22 is the red bar, and in every single case you can see there's a significant benefit to the algebra model that we're running now, the red bars. And you can see the average growth across there. You can draw an imaginary line there where the 3 would be, that's the national norm, and you can see that with this current model, pretty much every subgroup hits that number. The blue bar, only 1 does. All right, this is our final graph within this kind of section. Is we did want to share 8th grade regions results from last year, and you can see how the students did. The grade bands, I don't want to be misleading, I want to point it out. This is based on New York State reporting and ESSA requirements. It's kind of an interesting way they break out with what is considered a 1, a 2, a 3, a 4, and a 5. So if you look, it's like 0 to 54, and then 55 to 64, 65 to 79, 80 to 84. And I mention that because we're used to seeing like even jumps, and then when somebody doesn't have even jumps, it feels like it's disingenuous. And I just wanted to point that out, that it's not, that's actually how the state breaks it down. And you can see the number of students that scored, you know, a large number of students up in that 85 to 100, and you can see how they you know, trail off from there. So overall, even despite the challenges of last year, the students did really well. And this June, we don't yet have the results, obviously, but we're looking forward to see how the students do in this new model. All right, so just in terms of adjustments, we had seen this slide before. We're thinking about 2020, you know, next year, 2022-23, as we plan forward. Think about, you know, the adjustments. I'm not going to go through all of these. I know we've taken a lot of time, but these are the adjustments that we made this current year based on focus groups and surveys that we had sent to students and parents. We had made these adjustments for year 2, and we're thinking about year 3. These are some of the things that we heard this year from a survey that we had sent out in the fall. Increase the number of A, B, and C homework problems, increased support from the STEAM teachers, more professional learning opportunities for the faculty, and more and earlier AIS support. We have been hearing that it would be preferable if we could offer some opportunities during the school day for AIS. Recently, we had been asked by the Board of Education to provide some information with regard to how students are getting support with regard to tutoring specifically. So we did send out a survey. I had been asked to share the survey exactly. We did send out to all of the 8th grade parents a letter that had the survey questions in it. But we basically asked students if they thought the course was too easy, just right, or too hard. And we asked them which school they went to, Bell or Seven Bridges, and then we asked them where they are getting their support from, if they're getting support at all. So this is the graph that shows the level of challenge. You can see 57 students said the course is too hard, 70 students said it was too easy, and 180 are there in the middle that said it's just about right with regard to the level of challenge. We also asked them what kind of support do you access for algebra. So no support, you know, we got 119 students. Extra help with my teacher was the next one down. Math AIS, a family member, I have a private tutor. 92 students said they had a private tutor, and then a small number, 16, said they had attend a math program outside of school. So we're thinking one of the typical companies. I don't want to start listing them, but many of us are familiar with them that provide extra math support. So this was the distribution. We thought this was interesting with the data. We cross-referenced how the students rated, if they said it was too difficult, just right, or too easy, and then we laid over that how many of those students within those groups have tutors. So you can see that 29 students toward the left, the blue has tutors. You can see obviously the students that felt the course was too difficult, large number of them did have tutors. You can see the middle bar there where the challenge is just right, and then to the right, 10 students that thought it was too easy had a tutor. So this, I went back and forth as to whether or not we should put this in there, but I figured we'd give it a shot. So this one, I had heard that, that it's a challenge for us to figure out what's the impact of tutors on the success. How are they impacting growth, just as an example. And because a significant number of students are tutored. So what we did was, for argument's sake, just like a hypothetical, we sorted our MAPS data and we gave tutors credit for all of the highest achieving kids, the kids that grew the most. We gave to the tutors. So we took out the 90 students or 91 students that grew the most and said, okay, we'll give those to the tutors. We'll say we had no impact on that significant growth that all those students showed. So for the students that were left, how did they do? And I don't think it's even reasonable to say that students that are tutored are all like the top 90 in terms of the growth, but if we just did that as a hypothetical to see, and what we found was we still got a growth score of 1.67, so we still bested the previous model by a significant amount, so that our overall average score was a 4.5 if you include all the students, regardless of their tutoring or not. We don't have the specific information. We felt like we'd get better data from students if we made the survey anonymous, as opposed to having them put their name. Because if we had their name and if they were tutored, then we'd be able to really tease in and figure out more information. But we felt like we'd get more honest data from the students if they could do it anonymously. So this is even the tutoring impact. Although it's undoubtedly that the tutors do have a positive impact, this just shows that the program is also, the faculty is also having a positive impact on these students in terms of growth, because it's still, even by removing those top 91 student rowers, assuming they were the ones that were tutored, we still more than doubled the average growth score. All right, so in terms of next steps, thinking about some adjustments for next year, we're going to add an integrated co-teaching model, some additional professional learning and curriculum development this summer. We're working on redesigning some classrooms to support that collaborative work that Josh talked about, and additional math support. We're working hard with the master schedule to try to add some extra support for math during the school day. So we're working on those things. And then, in terms of recommendations to the Board of Education, I just encourage you to, really consider this data as you make decisions moving forward, that we wait until we get those end-of-year MAP scores and regions results. I think that will tell us a lot. That we continue to survey parents and students and run focus groups. We have been working, Jamie Edelman has been leading the work around MTSS, which is a multi-tiered system of supports. So we're going to work towards enhancing that system, build in additional opportunities for rigor to challenge students that feel like this course might be too easy, further refine our curriculum, strategic staffing decisions so we make sure our students have access to really powerful teachers, and consider inviting students and faculty to speak to you all so you can hear directly from them with regard to the program.